Hello and welcome everyone. I'm Ashfaq. I'm here with another short and precise tutorial on one of the most important topic of the modern computer science and computing research, and that is Internet of Things. So let's start. Well, these are the contents of my today's presentation. First of all, we'll look at what is basically Internet of Things, which devices are included. Then we'll see some terminologies of Internet of Things. We'll have a look at the future of Internet of Things. We will discuss the role of IPv6 in the progress of Internet of Things. And then we will, at the end, highlight some important points of BI intelligence report, and then we'll see some research areas for Internet of Things. So let's start. So Internet of Things actually refers to the ever-growing network of devices that feature a unique identifier, which is definitely the IP address for the internet connectivity, which in turn enables these communication that occurs between these objects and other internet-enabled devices and system. So in fact, Internet of Things is actually a combination of devices which are connected with each other using their IP address, and they can communicate with each other. But there are two important points to consider. The first one is that what are these devices? Which devices can be considered in Internet of Things? And the second one is the human involvement, or the amount of human involvement required. As far as the human involvement is concerned, so remember that in Internet of Things, these devices communicate with each other without the human interaction, which may possibly be in the form of human to human interaction or human to computer interaction. But these devices, in order to communicate, do not require human interaction. So in today's world of computers and internet, you are almost wholly dependent on human beings for information. Nearly 50 petabytes of data available on the internet were first actually captured and created by human beings, either by typing, pressing a record button, taking a digital picture, or scanning a barcode, whatever. And remember that 1 petabyte is equal to 1024 terabytes, and I'm talking about 50 petabytes. So all these data have actually been entered or sent or communicated or initiated by a human interaction. But in Internet of Things, we do not need human interaction. The things involved in the Internet of Things, or the devices involved, actually communicate with each other using their IP address and internet, and without any human interaction. And as far as the second point is concerned, let's have a look at which devices can be considered a part of Internet of Things. Okay, so the Internet of Things extends the internet connectivity beyond traditional devices like desktop and laptop computers and smartphones and tablets to a diverse range of devices and every day that utilizes embedded technology to communicate and interact with the external environment via the internet. Example of objects that can fall into the scope of Internet of Things include connective security systems, thermostats, car, electronic appliances, lights in household and commercial environment, alarm clocks, speaker system, and vending machines, and many more. So all of these things can be a part of Internet of Things, and you see that they are much more than the traditional devices like laptop, PCs, and cellular phones. Okay, so let's move forward. We'll have a look at some terminologies of Internet of Things in order to develop a better understanding of the concept. So the first two important things, the Internet of Things and the Internet of Things devices, I have just explained in the previous slide. So let's move forward. I'll give you a brief introduction of all of these terminologies. The next thing to consider is the Internet of Things ecosystem. While this ecosystem actually refers to all the components that enable businesses, governments, and consumers to connect to their Internet of Things devices, including remotes, dashboard, network, gateways, analytics, data storage, and security. The next is the entity. Entity basically refers to business, government, or any consumer using the Internet of Things infrastructure. Physical layer, the hardware that makes an Internet of Things device, including sensors and networks. This is actually referred to as the physical layer. Application layer includes the protocols and interfaces that devices use to identify and communicate with each other. Okay, let's move forward. The next thing is remotes. Now, remotes actually enable the entities that utilize Internet of Things devices to connect with and control them using a dashboard, such as a mobile application. They include smartphones, tablet, PCs, and smartwatches, connected TVs, and non-traditional remotes. The next thing is the dashboard. The dashboard actually displays information about the Internet of Things ecosystems to users and enable them to control their Internet of Things ecosystem. It is generally housed on a remote. Analytics. Now, analytics basically actually refers to the software system that analyzes the data generated by the Internet of Things devices. The analysis can be used for a variety of scenarios such as predictive maintenance. This is one of the biggest example of such scenario. Data storage, we all know this is the place or this is the point where Internet of Things devices is store the data. And the last thing is the network, which I discussed in the first slide as well, that the internet communication layer that enables the entity to communicate with their devices. By entity, we mean any business or any organization, and sometimes enables devices to communicate with each other. So that actually refers to that internet infrastructure that is basically required, or this, which is basically the backbone of Internet of Things. So that was some terminologies, and let's move towards the future of Internet of Things. Okay, so as far as the reach of the Internet of Things, there are more than 12 billion devices that can currently connect to the Internet. And researchers at IDC estimate that by 2020, there will be 26 times more connected things than people. So that just goes on to show you the importance of Internet of Things and how much significance it has as far as the future of computer sciences and modern world is concerned. So let's move towards another important thing, and that is the role of IPv6 in the emergence and progress of the Internet of Things. See, IPv6 huge increase in address space is an important factor in the development of Internet of Things. And as I mentioned here, according to Steve Leibson, the address space expansion means that we could assign an IPv6 address to every atom on the surface of the Earth and still have enough address left to another 100 plus Earths. In other words, human could easily assign an IP address to everything on the planet. An increase in the number of smart nodes as well as the amount of upstream data that the node generates, it is expected to raise new concern, and that is very important, and that actually gives us a path of the future research, because it raises concerns about data privacy and data security, which are actually two important areas of research in Internet of Things. Let's talk about a report generated by the BI Intelligence about Internet of Things. BI Intelligence has compiled an exhaustive and detailed report on the Internet of Things. That is your one-stop resource for all you need to know about the Internet of Things. The report gives a thorough outlook on the future of the Internet of Things, including following the big picture. Some important points of BI Intelligence reports have been mentioned here in my presentation. They say that IoT devices connected to the Internet will more than triple by 2020, from 10 billion to 34 billion. IoT devices will account for 24 billion, while traditional computing devices will comprise 10 billion. And by traditional computing devices, we mean the smartphones and the tablets and the smartwatches. Next, they say nearly $6 trillion will be spent on IoT solutions over the next 5 years. That's very significant. Businesses will be the top adopter of Internet of Things solution because they will use Internet of Things to lower their operation cost, increase their productivity, and expand to new markets to develop new product offerings. Sorry, and that is very important. And they also conclude that government will be the second largest adopters, while consumer will be the group least transformed by the Internet of Things. So that report that is actually openly available on the internet, and you can refer to that. There are hundred of points about Internet of Things, and which gives you a better understanding of where we are going with the Internet of Things. So in the end, another important thing that for students who are actually working in the Internet of Things and they are often confused about the research areas, I have tried to compile some research areas for Internet of Things. While the three important research areas, according to me, are the securities, the batteries, and the connectivities. Now, I'll discuss shortly one by one. Security and privacy are some of the hottest topics surrounding Internet of Things. The researchers are predicting 20 to 200 billion connected devices by the end of 2020. That is just icing on the cake because the lack of security may cause even personal tragedies, I'd say. And definitely, if we're thinking about private health, financial data, or home security, security and privacy actually is one of the prior important thing that must be considered for any new infrastructure or technology. Secondly, I mentioned the batteries. So lots of interesting Internet of Things devices are less interesting because they are relatively energy hungry compared to the environment you want to put them on. So that is very important. It's another important area of the research in Internet of Things. And the third thing, the connectivity. Connectivity is similar to the concept of batteries, or actually it involves the concept of batteries. Maybe issue in those far locations I mentioned before. So we have low power wide area network modules to provide connectivity there. With fewer gateways, they require cellular and Wi-Fi to connect to the internet. So that's again the battery and the power providence is one of the important issues to consider here. So that's basically what Internet of Things is. I've tried to define very precisely that what actually Internet of Things is. So let's conclude. So Internet of Things include different devices which are not the traditional devices but something more than that which I mentioned at the start. And these devices actually communicate with each other using the internet and their unique identifier, that is the IP address, and without any human interaction. Well, that's it. I hope the tutorial was helpful. Thank you very much, and please do not forget to subscribe to my channel. Thank you very much.